Welcome to doassignment-ca. Here is the problem. Gear A rotates with a constant angular acceleration of alpha A equals 90 radians per second squared, starting from rest. Determine the time required for gear D to attain an angular velocity of 600 rpm. Also find the number of revolutions of gear D to attain this angular velocity. Gears A, B, C, and D have radii of 15 mm, 50 mm, 25 mm, and 75 mm, respectively. Gears B and C are on the same shaft. Gear A meshes with gear B, and gear C meshes with gear D. Now let's work through the solution step by step. First, convert the target angular velocity of gear D from 600 rpm to radians per second. Multiplying by 2 pi over 60 gives exactly 20 pi, which is approximately 62.83 radians per second. Here is the gear train layout. Gear A meshes with gear B. Gears B and C are locked on the same intermediate shaft, so they share the same angular velocity. Gear C then meshes with the larger gear D. We need to trace the angular acceleration and velocity from A all the way through to D. At the mesh between gears A and B, the tangential accelerations at the contact point must match. So the angular acceleration of B equals the ratio of the radii times the angular acceleration of A. That gives 15 over 50 times 90, which is 27 radians per second squared. Because gears B and C are fixed to the same shaft, they always rotate together. Therefore, the angular acceleration of C is identical to that of B, which is 27 radians per second squared. Applying the same meshing condition between gears C and D, the angular acceleration of D equals 25 over 75 times the angular acceleration of C. That is 1/3 of 27, giving 9 radians per second squared for gear D. Since gear D starts from rest and has a constant angular acceleration of 9 radians per second squared, we use the kinematic equation omega equals omega naught plus alpha times t. Setting omega d equal to 20 pi and solving for t gives 20 pi divided by 9, which is approximately 6.98 seconds. To find the number of revolutions, we use the kinematic relation omega squared equals 2 alpha times theta, since the initial angular velocity is 0. Plugging in 20 pi squared equals 2 times 9 times theta d, we get theta d equals 200 pi squared over 9 radians. Dividing by 2 pi converts radians to revolutions, giving 100 pi over 9, which is approximately 34.9 revolutions. To summarize, the compound gear train reduces the angular acceleration from 90 radians per second squared at gear A down by a factor of 10, giving gear D an angular acceleration of 9 radians per second squared. Starting from rest, gear D reaches 600 rpm in approximately 6.98 seconds after completing approximately 34.9 revolutions. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.